Have you ever wondered where Linux stores temporary files, hardware connections, and system logs? Directories that you usually never touch, but Linux depends on them every single second. In my previous videos, we already broke down the root, the home, etc., and the bin, the core building blocks of the Linux file systems. In this video, we are going one level deeper. I will explain temp, dev, and var, what they are, why they exist, and what actually happens inside them while your system is running. If you have ever been confused by these directories, this video will finally make them make sense. So stay till the end. And if you have any doubts, questions, or suggestions, drop them in the comments. And don't forget to like the video if this helps you. The temp directory stands for temporary. It is used by the operating system and applications to store short-lived files. For example, when you open a PDF in your browser instead of downloading it, the file is stored temporarily in temp. Once the browser is closed, the file is usually removed automatically. Temporary files in temp are removed either by the applications or automatically during system cleanup or reboot. Everyone on the system has permissions to read and write to the temp. Now you might ask, if everyone can access it, doesn't that mean zero security? Not exactly. Linux uses a security feature called the sticky bit. The sticky bit prevents one user from deleting another user's files even though the directory is hold writable. Now let's just go ahead and verify that practically in our terminal. Now to prove my point for the sticky bit, let's just go ahead and list our files in long format. The very first column you could see here, this is the permission column, which I'll explain you in the upcoming videos with more details. The very first letter, which is D, stands for directory, R stands for read, W stands for write, and X stands for execute, which I'll explain in further details on the upcoming videos. But the most important thing I want to show you is this T. This T at the end of the permission column stands for the sticky bit, which is restricting one user to delete the files of a different user in a system. So any user can create files in temp, but only the file owner or root can delete them. Dev is just short for devices. As we already know, everything is treated as files in Linux, so the hardware is also not an exception. The dev directory contains special files that represent hardware devices. This is not a real folder stored on your desk. It is a virtual file system created by the kernel at runtime. Let's just go ahead and list our files in dev in a long format. So as you could see, they are not normal files, but they are device files. And in the permission column, the very first letter indicates the file type. So if it starts with a B, it is a block device. Think of it like disks and storage. And if it starts with a C, that's a character device, which is like keyboard, mouse, terminals, or data streams. You will also see two numbers here, which the very first number is the major number and the number in front of that is a minor number. The major number tells the kernel which drive to use, while the minor number tells the kernel which specific device the driver should talk to. So when an application accesses a device, it is really just reading from or writing to a file in dev directory. var stands for variable data, data that keeps changing while Linux is running. The var directory is like the memory of the Linux system. This is very different from bin, where command binaries like ls never change. Inside var, Linux stores system activity, and inside var log, Linux records what has already happened. This includes system boot messages, errors, user logins, crashes, and services starting or stopping. If you're coming from Windows, this is very similar to the Windows Event Viewer and completely different than Task Manager. While Task Manager shows live system usage like CPU and memory, logs record events, what happened, when it happened, and why it happened. Now to understand it better, let's just go ahead and list it in our terminal. Now to show you the new system events as they occur, we'll just go ahead and use the following command. So all gibberish text that you see here, they are the system events as they occur. To give you an example, let's just go ahead and create something here. I'll just create a new folder. And as you could see, it has been changed, which indicates that whatever event is happening in our system, it is stored here. So if your computer crashed, Task Manager disappears, but the log stays behind in var and log to tell you why it crashed. That's the power of var. It is the black box recorder for your Linux system.